Welcome to the Deep Dive. We're here to take complex research and, well, make it make sense for you. Today, we're looking at something pretty critical in the AI agent world, a kind of architectural crisis almost. We're talking about how these agents connect to the outside world using the Standard Model Context Protocol, or MCP, and why it's causing some major headaches.
Yeah, it's a huge efficiency problem that's been maybe hiding in plain sight. This standard way agents talk to external tools, your Slack, your CRM, databases, all that stuff, it's just fundamentally inefficient. Seriously, we're seeing data that suggests typical workflows using MCP, they can burn through like up to 98% more tokens than they actually need to. So our mission today really is to unpack why. Why does this standard MCP approach create this massive cost issue? Call it context rot. And then we want to dive into the shift towards code execution. So big players are pushing this, and it really changes the game for AI agents, especially for, important real-world stuff.
Right, and MCP has been the standard for ages. I mean, the idea was solid initially, wasn't it? A uniform way for agents to call tools. RPC, remote procedure call.
Exactly. Elegant on paper. Any agent could theoretically talk to any tool.
But like you said, once you move past a simple demo and try to use it in, say, a complex business setting.
That's where it falls apart. That uniform foundation suddenly becomes this massive token drain.
So the protocol itself isn't the villain here.
Not really. It's more about how we've been using it with these large language models. Specifically, how it interacts with the model's working memory, that context window. That's the bottleneck.
Okay, so let's break down this context rep. The first big problem seems to be what you called a tool definition bloat.
Yeah, think of it like this. The traditional MCP approach forces the agent to carry this, like, overstuffed backpack everywhere. It demands that all the tool definitions, the schemas, parameters, return types, even examples for every single function get loaded into the LLM's context right at the very start.
Even if the agent isn't going to use most of them.
Exactly. Even if it only needs one tool out of, say, 20, it has to lug all 20 definitions around in its working memory. We saw some figures just connecting two different MCP servers that can instantly eat up 20,000 tokens.
Wow. That's like, what, 10% of some context windows gone before the user even types a query?
Right, just dead weight.
And if you scale that up, I saw one example, a developer running 5 standard coding MCP servers.
Oh yeah, that one was wild. The definitions alone consume something like 97,000 tokens.
97,000, that's nearly half the context for a big model like Claude Sonnet 4.5, right?
Pretty much. Just describing tools the agent might never, ever touch.
And that clutter, it must cause problems beyond just cost.
Absolutely. Think about a real-world setup. A company connects maybe 6 different systems. Each has 15 or 20 tools. Suddenly, you've got over 100 function definitions swirling around in the agent's context. Costs go up, obviously. Response times slow down. But critically, it makes the agent less reliable. It's trying to find the right info and all that noise.
So it's more likely to get confused, maybe hallucinate parameters or call the wrong function.
Precisely. Its working memory is just jammed full of irrelevant stuff.
Okay, so that's the preloading problem. That sounds bad enough. What happens when a tool actually, runs?
Well, that leads us straight into problem number 2, the unfiltered fire hose of results. When an agent calls a tool using the traditional MCP method, the entire output, everything the tool sends back, gets dumped right back into the LLM's main context window.
The entire thing.
Yeah.
Regardless of how much data that is.
Yep. Let's say you use a tool to fetch a meeting transcript. Maybe it's a 2-hour sales call. That transcript could easily be 50,000 tokens long.
50,000 tokens.
Right. And maybe the agent only needs, I don't know, a quick 5-sentence summary from it.
But he gets the whole 50K anyway.
It gets a whole 50K dumped into its context. And here's the real economic killer. Let's say the agent's next step is to summarize that transcript to update a CRM record. It has to process those same 50,000 tokens all over again. You're paying to push this massive chunk of data through the context window multiple times.
So you hit context limits faster, and the costs just spiral.
Exactly. It can make complex multi-step tasks basically unaffordable or even impossible.
Okay, this MCP approach sounds pretty broken for complex tasks. Let's talk about the alternative. You mentioned the shift, moving the agent from just calling functions to actually executing code.
Exactly. Instead of forcing the LLM to wade through all that text and those huge data dumps, we lean into what these models are actually really, really good at, writing code.
Because they were trained on tons of code, right?
Billions of lines. They're exceptional coders. So the solution is basically stop treating tools like preloaded functions. Treat them like resources the agent can find and use. We call this approach Progressive disclosure.
Progressive disclosure. Okay. So if you're not loading all 100 definitions up front, how does the agent find the one tool it actually needs for a specific request?
It's actually a pretty neat architectural change. Think of the available tools like a file system or a directory structure. Each MCP server might be like a folder, and inside that folder, each tool or API is like a file. Often these are presented as, say, TypeScript API definitions, which are very clear for the model.
Okay, like browsing files.
Sort of. When the user makes a request, the agent doesn't just look up a function. It writes a little bit of code, maybe a simple alivs or grep command in a conceptual sense, to search that directory. It finds the definition for only the relevant tool, and just that definition gets pulled into the context when needed.
Ah, okay, so that tackles the definition bloat problem head on. Huge savings right there.
Massive.
But what about the other nightmare, that 50,000 token transcript result? If the agent is acting like a coder, how does it handle that massive data return without, flooding its own memory again?
That's where the other key piece comes in, the dynamic isolate sandbox. This is probably the most crucial part of the code execution model.
A sandbox, like a secure, separate place.
Exactly. The agent writes the code needed to call the external tool, right? But that code doesn't run in the main LLM process. It runs in this separate, isolated sandbox environment.
Okay.
So the tool runs, and maybe it returns that huge 50,000 token transcript. That massive result gets captured and stored in a variable inside the sandbox.
Ah. So the main LLM context, its working memory, never actually sees that raw, bulky data?
Precisely. It stays contained. Then the agent writes more code. This code also runs inside the sandbox. It might be code to filter that transcript, transform it, pull out just the key sentences for the summary, whatever the task requires.
All happening away from the main context.
Right. And only the final processed result, maybe just those 500 tokens of the summary, gets sent back to the main LLM context.
So the expensive context window is only used for the actual thinking and generating the final response, not for all the heavy lifting with the data.
You got it. It keeps the main context clean, efficient, and focused.
The cost implications of this must be enormous if you're cutting out the definition bloat and keeping massive results out of the main context.
The numbers are pretty staggering, yeah. We're talking about overall token usage potentially dropping to like 2 or 3% of what the traditional MCP approach uses.
Wait, 2 to 3%? That's like a 97–98% reduction?
In many cases, yes.
Mm.
That kind of saving fundamentally changes whether large-scale AI projects are even feasible.
Can you give an example?
Sure. Think about that customer support agent idea, handling maybe 200 complex tickets a day. Using the old MCP way, the costs could easily be, say, $400 to $600 per day, per agent, just in token costs.
Ouch!
With this code execution architecture, processing the same complex tickets might drop to maybe $40 to $60 per day.
$40 to $60 instead of $400 to $600?
Exactly. I mean, that's the kind of number that gets projects approved, right? It moves AI from a cool experiment to a core operational tool.
And it's not just cost, is it? What about reliability? You mentioned the cluttered context makes agents hallucinate more.
Right. So if the agent's working context is much cleaner, maybe just a few hundred relevant tokens instead of tens of thousands of useless ones, it's just inherently less likely to make mistakes. Fewer hallucinated parameters, fewer instances of calling the wrong tool, reliability goes way up, especially for critical tasks.
That makes sense. And this also unlocks things that were just impossible before, right? Because of those context limits or costs.
Totally. Take a complex e-commerce scenario. Maybe an agent needs to check inventory levels across Shopify, Amazon, a third-party logistics warehouse, and the company's accounting software to find discrepancies.
Okay, that sounds data intensive.
It is. Traditionally, pulling and comparing all that raw data might involve, 150,000 tokens or more. It would break most context windows and cost a fortune.
But with the sandbox,
The agent writes code, pulls all that data into the sandbox, runs a comparison script in the sandbox, and then only returns the final discrepancy report, maybe just 1,000 tokens to the main context.
wow, problem solved.
Makes complex multi-system workflows actually viable.
And you mentioned regulated industries earlier. Finance, healthcare. There must be big privacy wins here too.
Huge! This is a major selling point for them. Think about sensitive data, personal identifiable information, PII, patient records, financial details. With the traditional approach, that raw data might end up in the LLM's context, big compliance risk.
Right.
But with the sandbox model, the sensitive data can be pulled into the sandbox, and then the agent can run code inside the sandbox to anonymize or mask it before anything gets sent back to the main LLM context.
Ah, so the core LLM might only ever see masked or anonymized data.
Exactly. That makes meeting strict requirements like IPI much, much easier. The sensitive stuff stays contained.
That's clever. Is there anything else, any other benefits?
Yeah, one more really interesting one, agent learning or skills. Because the agent is writing code, if it figures out a particularly clever way to do something like parse a weird document format, it can potentially save that code snippet.
Like building its own library of useful functions.
Kind of. It can reuse that logic later. So the agent isn't just executing tasks. It's effectively getting better and more efficient at its job over time by building its own toolkit.
That's really cool. It actually evolves.
It adds real, accumulating value the longer it runs.
Okay, this code execution approach sounds like a slam dunk. Lower costs, better reliability, more privacy, smarter agents. Is there any downside? There has to be a catch, right?
There's always a trade-off, yeah. Traditional MCP might be inefficient, but it's also predictable. It's rigid, but you generally know what to expect. Code execution. It's flexible, powerful, but it introduces new kinds of risk.
Like what?
Well, you've increased the potential points of failure. The agent has to write correct code every single time. So syntax errors, logic bugs in the code it writes, problems handling unexpected data formats, these become real possibilities you need to manage.
So it requires more robust error handling.
Definitely. And the infrastructure is more complex. You need to set up and manage that secure, isolated sandbox environment properly. That's real DevOps work. It's not trivial.
Meaning it might be overkill for simpler things.
Exactly. If you're just building a quick prototype or you have very simple tasks with only a few tool calls and low volume, sticking with the traditional MCP might be faster and easier to get started.
So MCP isn't dead then. It still has a place.
Oh, absolutely not dead. MCP still provides really essential value that this code execution approach actually relies on.
How so?
Well, MCP is what defines that uniform RPC interface. It gives you the standardized documentation, the clear structure of how to call a tool. It handles the basics of connectivity, authorization, discovery, all in a standard way. It lets an agent connect to a brand new API and immediately understand, okay, here are the available functions, here's how I call them.
So MCP is good for defining and discovering the tools.
Exactly. We just need to maybe stop thinking of it as the mandatory execution layer for everything and more as the essential interface layer for tool discovery and standardization.
Okay, that makes sense. So if you're listening to this and you're building an agent, how do you choose? When do you stick with MCP and when do you make the leap to code execution?
I think a good rule of thumb is, for simple stuff, maybe fewer than 10 tool calls needed, low data volumes, quick prototypes where getting something working fast is key. Traditional MCP is probably fine. It's easier up front.
Yeah.
But if you're looking at complex workflows, lots of steps, heavy data processing or transformation, high volume where those token costs will really add up, or if you have strict privacy or compliance needs.
Then the code execution model starts to look much more attractive.
Yeah, then the upfront investment in setting up the sandbox architecture is likely well worth it because the long-term savings and benefits are potentially enormous, exponential even.
It really feels like a fundamental shift, moving these agents from just being function callers to being, well, actual coders that operate within a secure environment.
Yes, it changes how we need to think about agent architecture, efficiency, cost, reliability, the whole picture.
So what's the final takeaway? What should people be thinking about?
Well, maybe the provocative thought is this. As these LLMs get better and better at writing and running code reliably on their own, how do we balance our need for control and predictability with the incredible power that comes from giving agents more autonomy and flexibility? Is perfect, rigid control always going to be the priority, or will the benefits of letting sophisticated agents operate more freely using code eventually win out for complex tasks? That's a big question for the future, I think.
That is definitely something to chew on. And for you listening, how does this apply to what you're working on? Are you hitting these context limits? Have you started exploring code execution? We'd genuinely love to hear your experiences and thoughts. Drop them in the comments below. Let us know what you think.
Yeah, definitely. Hopefully this dive gave you a clearer context on where agent architecture might be heading.
Absolutely. And if you found this breakdown useful, please do give us a like. It really helps. And subscribe to the channel. Hit that notification bell so you don't miss our next deep dive. And maybe share this video with colleagues or friends who are also navigating the complexities of AI development. Thanks for joining us, and we'll catch you on the next one.